So imagine that you go to a website and type in your username and password and click login. What happens next is your login request will going through many routers and then reaching the server, right? So the question is, if someone have access to those routers, they can access your request. So they can extract the request and take your credential, right? Of course not, because if they do, you should already losing your bank account and social account, right? So under the hood, we have some cryptographic algorithms that helping to protect the user data. And in this video, we will discuss about that and some common application of it like HTTPS and JWT. I hope you enjoy. Let's go. The building block of cryptographics contains three algorithms. First one is symmetric encryption, asymmetric encryption, and then hashing. So let's go from the top. With symmetric encryption, it is quite simple. We're using the same secret key to both encrypt and decrypt the data. So let's go for the coding example with my favorite editor. So we have the encryption key defined over here. After that, we can have a cipher, which is an encryption function. After that, we can freely encrypting stuff, which is a hello string over here. In order to decrypt, we have another function, which is decipher with the same key to decrypt the value, and then we get back the original string. So the thing you can see here is the encryption value is very complex and very hard to know the original one without a proper key. So this method is usually used when two parties want to exchange message or data with each other. And of course, they must know the secret key first before talking with each other. Next, we have asymmetric encryption, which is quite funny because for asymmetric encryption, we have two keys, public and private key, and forming a pair. We use public key to encrypt the data and private key to decrypt it. For example, we have over here is a function to forming public and private key, and then we can encrypt a value which is a hello string over here to have the result by using the public key. In order to decrypt this result, the only way we can do is using the private key. You can never using a public key to decrypt the value using this asymmetric encryption. This gonna throws an error if you try to do so. The application of asymmetric encryption is that anyone in the world, when they have your public key, they can try to send a message to you, and you are the one with private key. So only you can decrypt it. So this is previously when we have symmetric encryption, both parties will know the same key. But in this situation, anyone can have public key and only you with private key can decrypt it. Yeah. The last one is hashing. It's quite different. We convert a data into a fixed result, and that result cannot be reversed back to original value. So for example, we have a code over here which is doing the hashing. We hash the hello string to a result. We can hash another one which will give us a different result. The main application of hashing is, for example, when we're trying to store the password, we're gonna try to restore it in a hash version like this. And then next time when the user log in, we will try to compare the hash version of the login password request with the original one to compare if it's matched or not. This method will avoid the case when the database got leaked or being stolen by someone else. So in that case, they cannot knowing the original passwords, so they cannot doing a serious action to our system. So there are a lot of applications with cryptographics, and I'm trying to discuss the common one, which is HTTPS and JWT. So let's go from the top. We have HTTPS. So from the introduction, I'm talking with you guys about the user that trying to send a request to the server. So in the middle, there will be a bunch of router that trying to routing the request to the final destination, right? And if someone having the access to one router, they can actually capture the request and exposing it to taking all of the sensitive information. That's very bad, right? One way we can solve it immediately is we encrypt the request and no one can read it anymore. But this will have another problems because now the user and the server, they must know the same secret before doing this encryption, right? One way we can solving this is maybe letting the user and the server, they are exchanging the secret on initial request, but it's still having a problems. And if someone listening to the router in the middle here, they can still capture those requests. So that's still very, very bad, right? And that's how HTTPS was born to solving these problems for us. For this method, first, the server must have the key pair, and on initial request, it's gonna send the public key to the browser. And after having this public key, the browser will try to check if this public key actually belonging to the domain, to our domain through a trusted CA, which is a trusted certificate authority. At this step, we can feel like it's done because the user have public key, the server, they have both the keys, so both parties can try to exchange the data, right? But there's another problems because public key and private key when trying to encrypt and decrypt will taking a lot of computation power compared to using symmetric encryption. So because of that, we should still have some additional steps so the browser and the server can sharing the same secret to do symmetric encryption. So next, the user gonna create a random secret over here, which will be a shared secret later. It's gonna trying to encrypt using the public key to the message, and this message will be sent to the server. After that, the server will decrypt it to take the secret. So now, finally, the server and the user having the same shared secret, so they can start trying to exchange the request and response safely from now. Going next, we have JWT, which is quite a common technique when we try to create a token for a user. So first off, we gonna imagine in the case when we have the microservice architecture with auth service and another service doing the business stuff. So imagine when the user trying to log into our system, the auth service will creating the JWT by signing the data using one secret, which is the key over here. And then when the JWT is receiving by the mobile app, it will send this one to another service to do another business stuff. So another service need to verify this JWT as well. And in order to verify, they need to know the same key as auth service. So that's quite a big problem because in this situation, more than one service having the access to the key. So this will increase the chances of leaking this key or being stolen or hacked by another person, and we should avoid this case as much as possible. So in order to solve this, we're having the symmetric encryption, which is if anything is encrypted using private key, will only be decrypted using public key. So using this method, we can signing the JWT with a private key and then sending it to the mobile app. After that, when receiving this JWT, the payment service and order service will using the public key to verify it again. So using this method, we can have a flexibility that any service can have public key, but only the auth service know the private key, so it's safer than the previous solution. And other than that, maybe we can share this public key to another system as well, so they can verify if the session key, the JWT, actually coming from our system or not. So cryptographics is really fun, right? It's the foundation of many security technique we have. So if you guys interested more, you guys can digging deeper using ChatGPT or Claude. I hope you guys have a good time in my video. See you in the next time.